Hey guys, welcome back to the channel. I have another PCM test, this time on a 2010 Ford Mustang GT, 4.6 liters. This is brought to me by a shop here in Manassas, Virginia. Customer concern is AC clutch not engaging. It was intermittently not cooling. It's a AC intermittently not cooling. It says that they tested relay tested as okay. I'm just reading the page in here. Grounding pin 14 of middle PCM connector with brown wire turns on compressor. Perform 4 pinpoint tests. M for AC in inoperable. Results give fine until AC relay. That's all I have. It shows me that the last digit on the bin number should be 135A15. And I want to show you that that is indeed the VIN number of the car. I have right now my oscilloscope connected to pin 14 on the middle connector, which is connector B. We got E, B, and T. All powers and grounds and communications, everything is in here. So I'm using my test platform here. And then my power supply connected to the top down with this same thing. So I'm in output tests and I'm going to perform the test. So I also have again the oscilloscope in channel A with the AC off as we have it right now. We're reading battery voltage because I have a test light connected through, pin 14, test light connected to power. So as soon as I turn that on, if it's working good, it should come on and we will see that on the drop on the oscilloscope, the test light, and also here. So if I turn it on, it is coming on immediately and we can see the drop right there immediately. So off. I'm going to do it a few times. On, off, on, off. We can see the test light coming on and off every single time. So I'm going to back up to show you how I get to this test because I asked him if he was able to perform bi-directional tests and he said no, I couldn't. So I want to show his name is McBall how to perform the test because sometimes this test is not present on Hotel or Top Down or any of those aftermarket scanners, but this one is. All right, so I'm going to completely get out of the computer. So we're going to see the VIN number and everything again. All right, so that is the scanner telling me that I am going out. So I'm going to put the scanner a little closer. I'm going to completely get out of here. I'm going to even power off the computer. So we are now power off. There is nothing in here. So we're going to power the computer back on. I'm going to establish an auto scan. This computer has the pads internally, so it should all be here, not a problem. Again, the last digits of the VIN number should be 135A15. 135A15. So that is, as you see, 2010 Mustang. All right, so we're going to quick access. The reason I'm doing this is because I want to show everybody that has a scanner that yes, you can do the bi-directional control. Sometimes it's not easy to assess that it's there, but it's actually there. So the ignition is on. I'm going to start trying to read the entire vehicle. We only have the PCM connected, not a problem. This computer communicates in high-speed CAN. I was on the uh, diagrams, and I'm going to show you that in here. Let's establish the communication first. So we are there. So let me stop or go over to the diagrams. So let me get a box so you guys can see where I am. All right, so we have in the PCM a connector 14, connector C175B, which is exactly the center one. We got the wire that is named ACCR. That will go over to the AC clutch relay right here, right? And pin 2, and then pin 1 will come over to fuse 46, a 5 amp fuse. that is also powered by the PCM relay. So when the PCM itself closes this circuit, it will power up the AC clutch and some of the things that we have here. If we go over to this power distribution box, that will power up all those components. And then after that, also on the power distribution box, onto this other connector. But yeah, so those are coils and some other things that I think is part of that terminal 87 on the PCM relay. But so focusing in here, so what this is will do is control that relay that it has power through this auto relay. So we are going to have, I'm going to have to ask MacBall to make sure that he has the power on pin 1. On the other side of the relay, which is the actual load, which is right here, the AC clutch, right? So we got the AC compressor clutch in here. So if we follow this, we have another fuse 25 with 10 amps, and it's hot all the times. So this should have constant power. When the relay is energized by the computer command on pin 14, it will close the contact and it will send power down to the AC clutch. So by the test that he told me, or he's writing in here, he put a ground. Let me just make sure. Yeah, ground in pin 14 on the middle connector. The clutch is energized. So that means that everything in here is indeed correct. So I don't suspect that we have any fuses or relay problems because he manually energized the relay and it worked and the clutch works. So what is the problem? All right, the problem that he can have if we go over to the actual clutch area, let me go over to first to the next diagram. So these are the powers and grounds for the computer. So we have grounds on pins 47, 48, 49, and 50 on connector C71, C175B, and then 10, which is a case ground. Then we will have power on pins 36, 35, 36, a keep alive power on pin 45, and then ignition on pin 46. Okay, going over to the AC, we can see the pin 14 is the actual same thing for the clutch. And we have communications on the 175B is high-speed CAN on pins 11 and 23. Let me see if I have, do I have, because I don't see, give me 1 second to get the one with the pressure sensors and all the stuff is in there. I'll be right back. All right, to make it a little easier on the eye, I downloaded the color wire diagrams, and I want to show you that indeed we have the AC pressure transducer, the cylinder head temperature sensor, very important inputs over to the PCM, right? So we need to have those pressures, that temperature in order for the AC to come on, right? Because if the engine is too cold or too hot, or there is not enough AC pressure, well, then the compressor should not engage, and that is the same computer protecting itself or protecting the system. This is a smart system, so it has an HVAC module. This will also have an ambient air temperature sensor, which is very important. It has also an evaporator discharge air temperature sensor. So all these are inputs that are necessary for that clutch to be engaged. If any of those inputs is wrong, let's say you're calling for air conditioning and it's the ambient air temperature sensor is showing that is you know 32 Fahrenheit. Well, why would I engage the AC compressor? Let me just open the blend doors and get cool air come in, right? And that can happen. If the evaporator discharge air temperature sensor is reading there is a minus 27 degrees, the computer will not engage the clutch because it thinks that, the evaporator is so cold, so let me just engage the blower and use that cold temperature on the evaporator until it gets warmer, right? So that's how and why the AC cycles on and off. If the pressure on the system is too high, it will turn the compressor off. If the pressure is too low, and I'm talking about the AC pressure sensor, then it will disengage the clutch. If the evaporator temperature is too cold, again, it will disengage the clutch and it will just use the blower because it's already cold. So let's just not stop this evaporator from freezing and let it warm up a little bit. And then when it gets to a certain temperature, it will engage the clutch again. If the ambient air temperature sensor is too cold, let's open the blend doors and then, you see what I mean? So this is the operation, the normal operation of a system like that. So this is all what is involved, and I'm going to have to ask him to perform those tests. So going back to what we were doing before, all right, so we're going to select the PCM. We enter the PCM. Gonna put a cursor here just to show you that I'm supplying 13.5 volts of battery voltage. Disregard this notes because that was for something else. We're going to go into actuation test, and this is probably where he couldn't find it, and it says like, yeah, there is no actuation for the fan, or sorry, for the AC clutch. All right, because if we scroll here, hopefully the camera is showing this properly. We got evap, fuel pump, gear. It says output test mode, and this is what it is. But let me just show you that if you read, there is nothing in here for relays. Okay, well then I cannot do it. Well, no, yes, you can. Enter output test mode. Key on, engine off. Very specific. This parameter indicates the state of the PCM. Output test mode. If the output test mode is on, then all PCM powertrain control module output devices are turned on, except for the cooling fan and the injector. So here it is, right? So what I want to do, and I always do, is when I'm here, I will add data stream. And all I really want, I'm going to look for the clutch, and this is going to be air conditioning clutch. That's the only one I need. So right now it's off. We have nothing on. Then what we were seeing before, on, we can see the immediate activation, and then off. I'm going to stop 1 second to capture. I want to go back to this in here because I can see a little bit of a noise in here. I want to make sure that we're not getting indeed an intermittent, even though this is a relay. My test light is probably drawing more than what a normal relay will draw, and this is probably what we're seeing in here. So let's disregard this and go over to the next activation. I think I did another one, right? No, I did not. So let's keep this the scope rolling. I'm going to do another one. Off, on, off, and now let me stop this. So yes, we see that in the first part of the activation, we can see this, and that is because it's not like in my test light. But if we go over to this, let me just get the hand. Right, because if we move this here, that's a touch screen. That's when I'm able to do this, and I can zoom in and zoom out. So if we go over to the next activation right here, and we do a zoom, if I get the zoom feature, come on. It's not letting me do it with that, so let me just get the zoom here. Now we see a cleaner activation. So I'm going to stress this computer more, but it is working. I cannot condemn the computer here at all. I have more than enough load here, and we can see that computer is pulling it down completely to ground, because if I go over to here at the bottom, we are around 360 millivolts, so that's pretty normal for a driver on a relay. So anything above 700, I will consider a problem on a relay, and I'm talking about 700 millivolts. If that is the case, the driver might be um, not good enough. It's not pulling enough, so the contactor cannot be pulled. But remember, this is going through a coil, so that's why we're seeing 369. That's very, very normal. That is the drop of that MOSFET or IGBT, depends on what Ford is using inside that IC. But again, I don't see, you see it's staying on. I don't see any problems whatsoever with this. I'm going to change my capture time so I can see more activations on the screen. As I am doing this, I'm going to try to get the camera back a little so you guys can see that both in the screen, the light, and on the scanner what I'm doing, but I don't see any problems. Again, sorry, I don't know if I was capturing the light. I'm gonna do it one more time in here. So we capture all, and I'm gonna leave it on. Oh, sorry, press the off button. And yes, we can see all the activations, all the activations, all the activations, and I can keep it on. So, MacMobile, I'm sorry, but there is absolutely nothing wrong with this circuit on the computer. I will contact you and then let you know. So I'm recording this for the customer and also showing guys what kind of tests you can perform. You can do the same thing on the vehicle bi-directional control, connect your scanner in the back and your oscilloscopes are on the back, and then you will be having a very easy way to prove that it's being pulled completely to ground. But if the clutch is being able to be pulled, that means everything is good. All right, guys, thank you so much for visiting the channel. Don't forget to subscribe. See you next time. Bye-bye.